Hello again, everybody. This is Michael, KE4EST, and I'm back here with the vacuum tube voltmeter, the Heathkit, and get it here. Show you what I did here. And the first thing I did, let me get this. Trying to look at the, bring it in a little bit. I'm not seeing. Okay, there we go. What I did here, I came in, I took this the selenium rectifier out, got rid of that, and what I did was here I took one of these terminal strips that I had and put that in there in place of the and I used to see that really long 632 screw there. I could have cut that off and went with a short one. It would have been fine. But you know, I left the original one in there in case, I don't know if I ever wanted to. I don't know what I was really thinking about, but I don't want to put that selenium rectifier back in, of course, but anyway, I left it. It's not gonna hurt anything. You really can't see it anyway like that. See, look. But anyway, coming out of the transformer here, secondary, we're going through this. This is a 1N4007. Okay. And then that, here's the dropping resistor I used. And that ended up being, I've got a bunch of these 5-watt 100 ohm resistors. So a lot of times I'll use these, and that's what I did. I put that in there, and it worked out pretty good when I hooked this up and did some voltage measurements. I think the manual says, you know, like I said in the first video, this is a really simple vacuum tube voltmeter. Of course, all of them's pretty much simple. I mean, there's some that get a little bit fancier, but I mean, there's not a whole lot to these things. But it said anywhere from 40 to 70 volts coming out over here, you know, on your DC to go to your plates. It's fine. And I measured 66.9, 67 volts. So I probably could have put a different resistor in here and dropped that down just a little bit more, but this, you know, it's within their specs. It's working good. Another thing, while I'm thinking about it here, I was researching this, and if you look, you can really see that a lot of this looks like, you know, a factory job. You know, initially. So I'm thinking that it was done at the factory. Inside, like I showed the last time, inside the housing that come off this, it had 11. What was it? Something November something 1949. The schematic is labeled, I think, 2 or 3 days before that, or something like that. So, then doing research, these came out in the first part of 1950. This particular one here, the V4. So what I'm figuring is, this was something they started getting made up and ready to go. So when they introduced it, you know, we got some to ship, you know, out or whatever, or to put in stores. I don't know exactly how they did a whole lot, if they had any stores. I guess in the big areas they did back then. So I thought that was pretty neat. This was probably, but the guy actually wired this up, you know, put the date in there, and I'm so glad he did, because it's pretty neat to see that, you know, this thing is, at the end of this year, you know, it just turned 68, it'll be 69 this year. Anyway, I did that. Okay. And then I came in here and replaced these. Let's see, I've got them here somewhere. Here's the capacitors that came out of it. These. The paper full with the wax in them. And this is 0.01, 1,000 volts. Now, what I did is replace, it's what these two blue ones are. Now normally when I'm doing something like this, I've done other radios and things before that I've, over the years, that I've restored. I would go with like the orange drop or something more, you know, closer to this. But I've got a bunch of these right here. These are 0.01, 2000 volt capacitors. In this circuit, and this, you know, for this, that's all it's needed. You don't need to have, you know, electrolytic or anything like that. It's not. It doesn't have to have a certain polarity. So that's what I did. I just put these in there, and it's working good. But I did replace this electrolytic here. Let's see. I think that's this one here. Nope, that's the same as that one. Well, see, now these are both 0.01s. Well, there it goes. This is 2000 volts, and I don't know why. There's no reason for that to be 2000 volts. Let's see here. Here it is right here. This is what was in there. It's going to get a glare on it. But 12 microfarad at 150 volts. I put in a 16 microfarad at 450 volts. And that seemed to work good. Let's see what else did I do. You can see. Oh, get back in shot here a little bit. I had to replace some wires. That one I showed you, I went back in there, replaced it, and there was a couple here that just looking at them, they were bad. So I replaced those. And then I think that was it. I'll come back, look at top side here. I put batteries in it. I had to do some work on the battery holders to get these here to make contact all the way through to get 3 volts. I'm going to go with batteries. These will last a long time. If you don't leave it on the ohm scale and leave it on, now if you do, it's going to drain your batteries faster. But if you're not using it, or especially not using it, at least, you know, measuring ohms or anything, measuring any kind of resistance, just flip the switch back to like DC positive, or just turn it off. But if you're going to be using it all day or something, you might want to leave it on to keep it warmed up, keep the tubes warm, keep everything stable. Just make sure you're like in DC or something. But you can go, I mean, there's YouTube videos, there's all kinds of things on the internet to go in on the internet to go into and take these, you know, and get rid of this. A lot of people will do that, but I'm gonna keep this original for now. And I mean, like I said, there's no reason really to. It'll last forever. But you can make up a battery eliminator circuit, and it'll tap off of the, usually the filaments voltage, drop it down for your 3 volts, and there you'll have that. Now I did have to go in. I did some preliminary, you know, checks through it because I don't want to bore everybody. I get long-winded enough anyway. Bore everybody. I went in, did some initial alignments. Now, this here, if you can see, of course you can. Better let me see that. I didn't chew that up. I don't know if you can see it on camera. It's, you know, a little corroded in there. I cleaned it up some, but the other two look pretty good. I don't know. Somebody really got the wrong screwdriver or something in that one. Of course, this one here was locked up. I could not get that to turn hardly for nothing. And then I did get these two to turn. One was working okay. The other one, it was all over the place. The AC calibrate, let's see, no, DC calibrate here. All over the place. You just barely touch it and turn it, and it was jumping everywhere. So I ended up taking these out, go back in here, unsolder, take these out, took them apart, cleaned them really good, electrical contact cleaner and all that, put them back in, and now they're nice and smooth. Same thing with these here. So what we're going to do now is we're going to go through the alignment procedure on this. I'll plug it in, and I'm going to turn it I'll turn it this way so you can now get the camera on the face. But I'll show you what I'm doing back here. Here's your AC calibrate, your DC calibrate, and this one here. Let's see it this back where we can see that. That's your AC balance control, your DC calibrate, and this is your AC calibrate here. Okay, tubes checked out good. They're close enough. If you get one that's really way off, you just can't get to zero out, then your triodes here and this 6SN7's shot, or the balance is way off on, where the tubes ain't matched, or the triodes inside ain't matched. So you just need to try to find something that's better matched for that. But anyway, let's turn it around. Let's do this. When I come back, we'll go through the alignment. Okay, we're back here, and I've got the camera on this, and we're going to plug it in there, and we're going to switch it on. And some DC. Let me show you something else while this is warming up. Zoom out a little bit there. This here, these probes here. Oh, I thought that. Oh, we got something loose there a minute, but we don't. These probes, I'll leave a link in the description. There's a guy I found on eBay that sells these, and I got the kit and made it myself. But this is, I made it a little bit different what he had it, but anyway, he even sent this here so I can stick it in there. Of course, I've got a label machine too. Probably looks like the same label gun, makes labels, but he already had them sent in the little kit. It comes with this clear heat shrink tubing, and you plug it into the meter, and then drill the hole here. I'd actually drilled it straight through, but I went in both sides and squirted it full of hot glue, and then let that set and clean that off. After I sorted all this in, then I put the label on there and put the heat shrink tubing over it to clear, and took the heat gun to it. Same way with this one here. Let's see, you can see in that. So that's how I done that, and then there's the one for the common. This here's your DC probe, and over here, of course, is your AC probe and for ohms. But anyway, let's come back down. I don't want to zoom too far out, and it looks like everything's crooked, but just the way I've got this set up here. Gotta remember not to stick my finger up in this thing. Okay, I'm gonna look at the alignment here, testing alignment. And first thing, of course, says do is turn on the switch and let it warm up for a minute. Set selector to DC positive. Check operation of zero adjust control. Turning this control should move the meter pointer to about half scale and to zero. Set pointer to zero and check if it remains on zero and switch to DC minus. If there is an appreciable zero shift, the tubes must be aged, and these should be aged. But first, complete the initial test. So what it's saying is, here's your adjustment here. And get that right on zero. So, and then when you go this, you see it does move a little bit. And back to DC plus. If it moves more than one division, so if it, let me come in on this just a little bit. If this comes up, we're at zero, here's one division here. If we come up, it moves more than that, then we got to go through another thing. But anyway, so we're at DC positive. Okay. Insert the DC test leads. Set the selector switch to DC positive. And the range switch to 3 volts. Connect the calibrated flashlight cell batteries. And see what they want you to do is, because they're usually, if you put 2 of them together, you get 3 volts. So if this is, if you're at home, especially back in 1949, you got a whole lot of extra, things or a power supply sitting there, to go by to, set it up. But what I'm going to do is I'm going to use, I've got a power supply over here set right at 10 volts. So I'm going to, let me just double check. And let's see, yeah, DC calibrate and AC calibrate. So I'll go in here very carefully. Alright, we'll set this here, which should be 10 volts. We are on the, let's go to the 10 volt scale. Okay, and it's pretty close. So let me get in here. Let's see how I can adjust that. I'm adjusting that DC calibrate. Put that on 10 volts. And as I just turned this on. As it warms up, and it'll do a lot better when it's in its metal case. Now here I'm talking, there's movement in the air coming across these tubes. Always kind of keep that on your 0 there. Okay, so let's go up to the 100 volt scale. So the 100 volt scale, this should come over. This will be 0 to 100. We're reading this bottom scale right here. Okay, so 0 to 100 instead of 0 to 10, so this will be like 10, 20, 30, 40. So let's see how that's doing. Oh, wait a minute, am I on the wrong? Yeah, I was on the wrong side. This will be, okay, so now we're on the 10 volt scale here. Let's go up to the 30 volt scale, and we go on there. And if we look at it, so just a little hair past 10. I can go in there and adjust that just a little bit. Okay, so at the 10 volt scale. See how that's off a little? And we're back. Well, that's still off a little there, isn't it? Just gotta keep doing this. That's all the way down to 9. I went the wrong way with it. Alright, let's see. That's close. It's a little over 10 volts anyway. That's pretty good. Okay. Now, and then it goes into doing the ohms. And this, what you do is you take this this ohms adjust, put that right on the INF or infinity. Some of these meters will have a it'll say, it'll have the little actual infinity symbol, the sideways 8. And then what you want to do is you grab the red lead. Oh, let's see. Let's back this out just a little more so you can see what I'm doing here. Because you get your 0 adjust, or 0 adjust and your ohms adjust. We're on ohms now. And I put that round infinity. Okay. Now let's short this out, and that should go right to 0, and it is. And adjust it. Okay. You see that, how that's doing that? Kind of land in a different spot. In here, really, I need to go in here and lightly brush that a little bit in there. Gotta be really careful with this movement. I need to pull this off and go in and do that because you can see how it's. But anyway, that's pretty good there. So let's go over here and let's move this off here. Let's move that test rig off. Okay. And where are we at here? Put this across a 10K resistor. Now we're on the top scale. We're on times 1000. Let's back it out just a little more here. Oh, just bring it down. Don't make the camera jump too much for you there. Okay, we're on the times 1000. And if you look there, we are 10. And this is a 5% tolerance resistor. But there you go. There's so 10 times 1,000, 10,000, and it's a 10K resistor, brown, black, orange. So that looks like that's doing pretty good. Now let's go to AC. And when you go to AC and the adjustment, you have, besides your AC calibrate, you got AC balance control. So what you want to do is grab this 0, put it on 0. Let's go back to these two and just bump it. Go back to this. And you can sit and play with this all day, as I found out before. And the AC balance control, which I've set before and it messed with it. So I've got, before when I would go from AC to DC minus, that would go up a pretty good a bit. So I've got the AC balance control already set and I don't want to mess with it again. I did it off camera. But that's not bad right there. That's moving. We go to AC. Okay. And we're going to check some AC. So I'm going to go right there. And real quick here, I'll just keep moving my wires around here. Let's put that here. And let's go to 30 volt scale. And let's see what we got here. This should be 14 volts. So there we go. And I'm sorry if you can't see that really good. Maybe I should bring this. I had that set. This auto balance on this thing I don't think I like. I'm thinking I need to get my other camera next time and set it up. I thought I'd go with auto, but I don't know if I like it. Alright, let's go. There we go on the AC side. I don't want to plug it in the wall or try to do anything on the anything much higher than that. While on camera, you know, I'm trying to watch the monitor on the camera. I'm trying to watch this and that. And I don't want to accidentally grab something and shock the crap out of myself. Because that's the final thing. And it really, it's not a whole lot to it. You can go and online download the manual. It's a really short calibration. Ohms, there's nothing to do but this. And the AC, there's an AC, and it's pretty much on it from before when I did it off camera, because I had to go through a lot. I was going to do the whole thing on camera, but nothing was calibrating right. So I was like, well, I bet, you know, who knows how much it's got used or not used or anything since 1949, you know, 68, 69 years. So I pulled those pots out, those VRs, and I took them apart, cleaned them, put them back in. But anyway, there it is. And so I will shut it off now and get it back in its case and put it on the bench and use it. So I hope you enjoyed this video and the video before this. If you didn't see the first part of me taking it apart to start with and going into it, you're more than welcome to go over there to that part 1 of this video and watch that. And until next time, this is Michael, KE4EST 73.